Okay, this is a walkthrough for the practice test for the first test. So if you scroll down here, you can see the practice test is here and the real test is here. The practice test does not count toward your final grade. It is just a practice test. The real test does count toward your final grade. However, you can take it twice, and I will take the higher of the two grades. The real test is randomized, so everyone will get a slightly different test, but each question is drawn from a pool that is similar to the questions on the practice test. So there are 10 questions on the practice test. There are basically 10 pools, and each pool consists of questions similar to its parallel question on the practice test. You can open the real test at any time. Once you do that, you have 1 hour to complete it. You can take it twice. The test is open book and open note. I know a lot of people have been doing a lot to try and make online testing more secure to keep people from cheating by looking at their notes. So they ask you to have cameras all over your room and that sort of thing. And I find that very intrusive. So rather than asking you to set up cameras to be sure that you're not looking at your notes, I'm going to let you look at your notes. That this should just encourage you to keep good notes. Okay, so let's take a look at the practice test. You open it up, and it says no time limit because this one is the practice. It's got a deadline on it, but that's just so that it appears on your calendar. There's no actual penalty for doing anything late in this class, and in any case, this isn't even a graded exercise. So let's just click begin. So when you open the test, you can see that the first two questions are about vocab terms that we're using in this course. The first one is argument, and the second one is validity. These are central concepts for this course. Everything is going to be built around identifying arguments and assessing their validity. So this is pretty important. So that's why I've got those two concepts in the practice test. The real test will pull randomly from a pool that for the first question, it includes definitions of argument. It also talks about statements, the definition of a statement, and the definition of indicator words. The pool for the second question has questions about validity. It also has questions about soundness, strength, and cogency. So all of our evaluative terms for argument are in the pool for the second question. Also, for each pool, I'll ask the same question multiple different ways. My theory is that if you really understand a concept, you should be able to do a lot of different things with it. You should be able to identify its proper definition. You should be able to put out its proper definition, if prompted, without having to select it from a list in a multiple choice question. You should be able to identify examples of it. All of those kinds of questions for all of those kinds of terms are in the first two questions on the real test. So let's look at our examples here. The first one talks about argument, and it does it as a fill-in, as a short answer question. Explain how an argument is defined in this course in 10 to 30 words. Now, I've mentioned how argument is defined repeatedly, and you can just actually pull the definition used word for word, and that's a fine answer. So if you have a printed copy of the text, you can see here on page 9, it says an argument is a connected series of statements designed to convince an audience of another statement. Also, if you look in the back of the book, or at the end of your PDF file, if you don't have a printed copy, you can find the glossary. And again, in the glossary, we define an argument as a connected series of statements designed to convince an audience of another statement. This is also in the PowerPoints. I could show the PowerPoint on the screen here, but I don't feel like calling that up, so I'm not going to bother. In any case, you can just put that down word for word. An argument is a connected series of statements designed to convince an audience of another statement. Now, in fact, you don't have to give that word-for-word definition. You can paraphrase it, and ability to paraphrase is another sign of, that you've grasped a concept. There are two ideas that I would want any acceptable paraphrase of the term argument to include here. One is that an argument is an attempt to convince someone or provide evidence for something, right? So it's not yelling, it's providing evidence. And the other thing is that an argument is composed of statements. And those are the two basic elements of argument in logic and also in critical thinking. So another example of an acceptable definition of argument for this course is would be something like, an argument is an attempt to persuade someone using a set of statements called premises. So that would also be acceptable, and it helps to spell persuade correctly. Okay, so the next question asks about validity, and this time I'm asking about validity in the form of a multiple choice question. But I could do it as a short answer question or an identify examples kind of question, and this could also be about some of the other evaluative terms that we're looking at, like soundness, strength, or cogency. But in any case, here we can just run through. It helps always with multiple choice questions to read all of the options and think about them. Don't just click on the first one that seems right to you. An argument is valid if the truth of the premises would make the conclusion likely. That's our first option. That is not the correct answer. That is, in fact, the correct definition for a strong argument, not for a valid argument. So that's close, but it's not exactly right. An argument is valid when the premise is true and the conclusion is true. No, that's one I've been trying to steer you away from. Validity isn't about having true statements. We've got arguments with all sorts of valid arguments with all sorts of false statements. It's about the connection between premises and conclusions. An argument is valid if it makes a legitimate point. Well, that's how we might use the term valid in ordinary speech, but that's not how we use it in this class, which is a logic class. It's not how we use it in the parallel class, the critical thinking class. An argument is valid if it's impossible for the premises to be false and the conclusion true, is one option. An argument is valid if it's impossible for the premises to be true and the conclusion false. All right, so the correct option is the last one here. And the second to the last distractor option is just there. It just switches some words around, so it might be confusing. So this is a question that you should be able to get right on an open book and open note question, as long as you're reading carefully and paying close attention to what you're doing. So the next three questions all have the same instructions. And so the instructions are off to the side here, and then the questions are over here. And on the test, on the real test, you're going to have this set of instruction and then 3 randomly pulled passages off to the other side. So with this set of questions, the most common reason people lose points is that they don't pay full attention to the instructions, and they leave something out. So read all the instructions carefully. For passages 3 through 5, identify each passage as an argument or a non-argument and justify your answer. If the passage is an argument, write it in standard form and remove all indicator words and keep the conclusion as a complete sentence. Write the indicator words separately and state whether they are premise or conclusion indicators. If the passage is not an argument, state what kind of non-argument you think it is, such as a narrative or expository passage. So for problem 3, we get this passage. It's in a chemistry textbook. Remember, the part in italics gives you the context that this is occurring in, and then the part in regular typeface is the actual passage. So the actual passage says there are 3 familiar states of matter: solid, liquid, and gas. Solid objects ordinarily maintain their shape and volume regardless of their location. And then what follows is also definitions of liquid and gas. So this is a passage. It's composed of statements. All the statements are definitions, though. And this is also happening in a chemistry textbook, where the textbook would probably just list definitions that they expect the reader to memorize or to know. So this is not an argument. We've got a bunch of statements, but some of them are not providing support, logical support for others. So they're not, some passages, some statements aren't evidence for other statements. They're just 3 independent definitions that have been arranged in a nice order. So what we're going to say here is that this is not an argument. This is an expository passage. Statements. The statements do not provide evidence for other statements. Some statements do not provide evidence for other statements. There. Okay, so for the next question, we scroll down, and we use this scroll bar here because these 3 questions are all attached to this set of instructions, right? Oh, and it came out in a different order than I expected. Huh, that's funny. Okay, in any case, you stop and ask directions for how to get to a theater. You aren't far, but you're going the wrong direction. You want to turn around, go 5 blocks, and then make a left at the light with the gas station. It's just a few blocks after that on the left. So is this an argument? Well, no. I mean, because it's not even composed of statements. These are more like commands. I mean, it's a few blocks after that on the left is a statement, but go 5 blocks and then make a left is a command. These are directions to how to get someplace. So this is not an argument. Directions on how to get someplace are made of commands or requests, something like that. Right? It's not an argument. All right, last up. Susan is discussing politics with Steve at the office. Look, a basic principle of fairness says that people who make more sacrifices should get more benefits. Therefore, nuclear power violates basic fairness because people who live near nuclear power plants take on greater risks but do not receive greater benefits. So right away, 2 words should jump out at you. Therefore and because. Those are what we have called argument indicator words. And so, in fact, this is reasoning. Susan is trying to convince Steve that nuclear power is unfair. So actually, we want in our instruction, so first we say this is an argument. Susan is trying to convince Steve of something. Indicator words. Well, actually, say premise indicator word. Because conclusion indicator word, therefore. And then the other thing we need to do now is put the argument in standard form. So the conclusion is what comes after the word therefore. So let's just grab that. Nuclear power violates basic fairness. And I can cut and paste, that's fine. You can also paraphrase. If you're writing out by hand, it's easier to paraphrase. If you're on the computer, it's easier to cut and paste. You just have to make sure that things are complete statements. So nuclear power violates basic fairness. That's our conclusion. We'll draw the line above it, and then we have two premises. And those are the other two statements in the passage, P1 and P2. So P1 is a basic principle of fairness says, blurdy blur, make this a full sentence, and then people who live near nuclear power plants take on greater risks but do not receive greater benefits. So there we go. It's an argument, premise and conclusion, indicator words, and then standard form. Notice that this passage is conclusion middle. That's an awkward way to write, but people often will speak that way in casual conversation. And remember, the conclusion of the argument in ordinary speech can be at the beginning, middle, or end. Sometimes it's at both the beginning and the end, and that's actually a very powerful way to write. In this case, this one was conclusion middle. All right, and then for the remaining 5 questions, I'm going to switch back to an earlier recording where I'm wearing big dumb glasses that I thought would help me with eye strain. The next set works the same way as the previous one. So for questions 6 and 7, you have to decide whether it's deductive or inductive. And again, the questions are linked to the instructions, so you use this inside slider. Number 6 is a question about math. So this is deductive. Math is deductive. Is one easy answer. Another answer is that they're reasoning with attempting for validity, or maybe you could even say the argument is deductively valid. All of these would be acceptable. So when you put it in standard form, you're going to say the conclusion is the answer has to be 5. And then you've got a premise, and we'll just give the 2 statements as written, because that's going to be the easiest way to do this. Okay. The problem says blank plus 7 equals 12, P2. If a number added to 7 equals 12, then subtracting it should give me that number. Conclusion, the answer is 5. And our indicator word is so. I can't emphasize enough here that you need to do all 3 parts of the answer. You need to tell me that this is deductive and why it's deductive. You need to write the argument in standard form, and then you need to write the indicator words. The next one is about Ernest Rutherford discovering the structure of an atom. And this is empirical science. It's not about pure math and numbers. It's about the physical world, and so the reasoning is going to be inductive. Empirical science is inductive. Okay. So, and the conclusion here is that positive charges are not evenly distributed across the atom. Whenever you're dealing with argument, it really helps to go conclusion first, because the conclusion structures everything else. Positive charges are not evenly distributed throughout the atom. And Geiger and Marsden, when I asked them to shoot these alpha particles, they found that a small number of them were deflected at a wide angle. Let's just do it like this. Okay. We're going to say that this is a premise. And then the best explanation for the phenomenon is that charge is not evenly distributed. And so that's going to be a P2. All right. This one actually has a premise, the conclusion first and last. The negatively charged atoms form a shell around the positively charged nucleus, and the best explanation, and positive charges are not evenly distributed across the atom. Those are both basically statements of the conclusion. And so I'm paring that down to rather than write the conclusion twice, I just used the final statement of it here. Positive charges are not evenly distributed in the atom. And you could say that the best explanation of this is an indicator phrase, or you can just say no indicator phrases. There's nothing in here that's a strict synonym for because or therefore. All right. Last three questions are about the additional concepts from Chapter 3. And I have formatted these simply as short answer questions because it's the way they're formatted in the test. It's awkward to translate them online into the kinds of multiple choice questions that Canvas allows me to ask. So I'm just going to do it like this. And what you're going to do is just write your answers in this blank. So for number 8, you have to identify each statement as a tautology, a contradiction, or a contingent sentence. So you're going to say statement A. Statement A is cannibalistic humanoid mutants live in sewers of New York. This was the premise for an 80s horror movie. But that's not the point. The point is that it is a false statement that we can imagine being true. It seems to be able to go either way, so we're going to call this a contingent statement. B, my house is shaped like a circle with 4 corners. A circle cannot have 4 corners. This is a contradiction. If Bob is a bachelor, he is unmarried. That's a tautology, right? Because bachelors, by definition, are unmarried. If Kermit the Frog is an amphibian, he spends part of his life cycle in water. That is a tautology. An amphibian is defined as an animal that spends part of its life cycle in water. Okay, and then E, most cars run on gasoline. This is a contingent statement. It happens to be true now, but it could be false if electric cars become more popular. Okay. Number 9, it deals with pairs of statements. And you just need to look at each pair and decide whether they are equivalent, contradictory, or neither. So A, all students who study will pass the test, and if Jeremy studies, he will pass the test. This one's a little bit tricky. You might think these are equivalent because the first statement implies the second. However, the second statement does not imply the first. And when things are logically equivalent, they both imply each other. They say the exact same thing. So for A, we're going to say neither. Okay. B, Brian is sitting to the left of Kathy. Kathy is sitting to the left of Brian. And if they're sitting in a row and not on top of each other, these statements are contradictory. If one is true, the other has to be false, and vice versa. C, elephants are friendly social animals. Elephants greet each other by intertwining their trunks. These two statements are not equivalent, but they're not contradictory either. They're both true. So that's neither. D, elephants are friendly social animals. Members of the two surviving species of the family Elephantidae are friendly social animals. So these two statements are equivalent because the term elephant is equivalent to the statement the term members of the two surviving species of the family Elephantidae. And you probably didn't know that, but you could figure out from the context that that's right. So this is equivalent. And then E is neither. The last question works the same way. It's done as a fill-in-the-blank question because getting the format to match what on Canvas just was too complicated. So we've got 4 statements here, and you want to find out whether they are consistent. Different combinations of them are consistent. Remember, a set of statements is consistent if they can both be true. So, Q1, Gottlob Frege was the sole inventor of quantificational logic. You might not know who Gottlob Frege is. By the end of the term, you will know what quantificational logic is, because that's what we're studying in the second half of the term. In any case, Frege was one of 2 people who discovered it. But that it is, if he was the only person who discovered it, it would be compatible with saying that Bud Powell did not discover it. So A, consistent. But when you look at Q1 and Q2, those are not consistent. Either Frege discovered it on his own, or he discovered it at the same time as C.S. Peirce. So we're going to say B, inconsistent. For C, we've got 2 and 4. 2 and 4 are consistent. 1 and 3 are inconsistent. And 1, 2, and 4 are inconsistent. So there you go. Once you fill in all your answers, you should go back and look up and double check them. I'm not going to walk you through that, but it's good to do that. Be sure that everything's filled in. Be sure that you're confident in your answers. Hit submit. After you hit submit, it's going to say something like this, 10 out of 100 points. And you might think, my God, I did terrible. But that's because there's only one question on the test that was given to us that is gradable by Canvas. All the others I have to grade by hand. So your real grade won't appear until I go in and grade all the other questions by hand. Now, you may actually have more questions that are machine gradable or fewer questions that are machine gradable because the task that you are going to be given is randomly generated. So you may have noticed that the questions came in units on certain topics. Each of those is going to pull a question randomly from a pool of questions similar to that one. So for instance, with the argument, explanation, or neither thing, I have a pool of passages, 1/3 argument, 1/3 explanation, 1/3 neither, and the Canvas is going to pull a question randomly from that pool. Finally, I know a lot of people have unreliable internet. I know I do. And it may be that your internet will go out or some other problem will happen during the test. If that happens, don't panic. Just email me. We'll figure it out. Okay? I feel like there are a lot of fears around online testing, especially for people who are older. My children find it perfectly natural, but I don't want you to have to deal with that kind of stress. I'm making this I'm trying to make this as stress-free as possible. So if you have technical issues, just let me know. I can reset the test.